Now, dear student, let us discuss about what is the difference between chemical vapor deposition process and physical vapor deposition process. So, where you can basically apply a chemical vapor deposition process and where you can basically apply a physical vapor deposition process, is I have discussed that a physical vapor deposition process is a process of a physical removal of a precursor material or a source material which is usually present inside the reaction chamber. That source material is evaporated, converted into a plasma or gaseous phase material, and then the same material is transported onto the surface of the substrate. So with physical vapor deposition process, basically you deposit a same type of material which is a source material onto a surface of the substrate. Whereas in case of chemical vapor deposition process, you basically have a reactant or which is present uh, or reactant or a precursor material which is present outside of the reaction chamber, and the reactant in a gaseous form is incorporated through a carrier gas inside the reaction chamber, and then the reactant is transported onto the surface of the substrate where a chemical reaction takes place between the reactant and which result into a thin film. So basically, in a simple word, in physical vapor deposition process, you deposit a same type of material on the surface of the substrate by evaporating material through electron beam evaporation or thermal evaporation or through sputtering. Whereas in case of chemical vapor deposition process, you deposit a thin film on the surface of the substrate by transporting a precursor in a form of a liquid, in a form of a gas onto a surface of a substrate externally, and when it is transported on the surface of substrate, the precursor material get reacted chemically and which result into a thin film. So now let's discuss the difference, the comparison between the chemical vapor deposition process versus physical vapor deposition process. So student, please note that in a physical vapor deposition process or technique, atom or plasma are moved and deposited on the substrate, while in a CVD process, the gaseous molecules will react on the surface of substrate. So in physical vapor deposition process, basically you convert a precursor material which is usually a source material which is present in the form of solid inside the reaction chamber. You basically convert it into atom or a plasma. The precursor material or a source material is converted into a plasma or atoms of plasma due to a thermal evaporation, especially in case of closed space sublimation system, or by electron beam in electron beam operation system, or by sputtering. So they basically all this technique basically convert a source material into atom and plasma, which is then transported and deposited onto a surface of a substrate as a thin film. Whereas in a case of chemical vapor deposition process, the reactant is basically, which is usually in the form of solid, and sometimes it may be in the form of liquid, is converted into a gaseous phase, and then it is transported from outside inside the reaction chamber, and then it is deposited by doing a chemical reaction on the surface of the substrate. So in this way you get a thin film on the surface of substrate by chemical vapor deposition process. Physical vapor deposition process operate at relatively low temperature, around 250 degrees centigrade to 450 degrees centigrade. Whereas for CVD deposit at relatively high temperature in the range of 450 degrees centigrade to 1050 degrees centigrade, and even up to 1200 degrees centigrade. So if I simply explain this, in CVD process, usually a source material is heated, okay, the source material may be heated by thermionic emission, okay, or the source material may be heated and evaporated by electron beam evaporation, sputtering, or by pulse laser. So a small region of the source material usually is heated by electron beam or by sputtering or by pulse laser. So that small region, very small spot, have a very high temperature, and that is basically cooled by a cooling system which is connected with a source material. So that's why a small spot of the physical vapor deposition system have a temperature in 1000 Kelvin. However, overall the temperature inside the reaction chamber is less, okay. So due to this, basically CVD is a focused technique, and you can basically deposit a thin film at low temperature around 250 degrees centigrade to 450 degrees centigrade. Just please note that in CVD system usually the substrate holder, a substrate holder is a holder on which substrate is placed, is slightly heated for better diffusion. So usually substrate holder is basically heated around 250 degrees centigrade to 450 degrees centigrade, and after that a film is basically deposited. So you don't need a kind of like high temperature for CVD system. You just need operating system like electron beam or pulse laser uh, or thermionic type of filaments. So basically they heat a small region of the substrate holder of the precursor of the source material, which has very high temperature, but they are connected with cooling system. So overall the temperature of the reaction chamber during a physical vapor deposition process is less. It's around 250 degrees centigrade to 450 degrees centigrade. Usually this temperature is used for heating a substrate for getting a better adhesion of a thin film on surface of substrate. Whereas in case of CVD process, you just please note that the operating temperature is a range of 450 degrees centigrade to 150 degrees centigrade. Please note that the temperature of CVD system may rise up to 1200 degrees centigrade and even more. It depends on a situation in which you want to deposit a thin film. Why a high temperature is required for chemical vapor deposition process? Please note that first, the precursor material, which is in the form of usually in the form of a solid, or in liquid injection chemical vapor deposition system it is in the form of liquid, they are heated in a stainless steel container, okay, and which is present externally. So they are converted into a vapor phase or gaseous phase molecules. Now these molecules are transported by a carrier gas inside the reaction chamber on the surface of substrate. Now you need to decompose the precursor gases. For that, a higher temperature is usually applied across the reactor. So due to the higher temperature is in the range of higher than 450 degrees centigrade to 1200 degrees centigrade, and at that temperature there occur a chemical reaction which result into a thin film. So for chemical reaction or decomposition of a precursor material on the surface of substrate, you need a higher temperature in chemical vapor deposition process. Whereas in physical vapor deposition process, you just need a higher temperature at a very small spot of the source material. And after that, the whole precursor reaction chamber is usually operated less than 450 degrees centigrade. Dear student, this is very important property of the physical vapor deposition process, that physical vapor deposition process is line of sight process, which means it is not ideal for coating non-visible surfaces. You can coat very short edges but not with a CVD. Why? The PVD is a line of sight process. Basically, in a PVD process, you have a source material which is placed on as so you have a source material, and you have a substrate holder on which a substrate is placed. So both of them are adjusted inside the PVD system in a specific direction. So basically you directly evaporate a source material from the source holder, and is directly transported onto the surface of the substrate. So if the substrate has an edges, you can easily deposit the substrate material with even with their edges. So you can use you can use a PVD process for depositing edges of the substrate material. That's the reason that PVD is the very important or essential part of the tooling industry. Basically, you do the coating of the two different kind of tools by physical vapor deposition process. Whereas in case of CVD process, CVD basically just you have an evaporated gas which can be deposited everywhere on the surface of the substrate by chemical reaction. So it is difficult for for coating edges of the sharp edges of the substrate material with a CVD process. Physical vapor deposition coating may be much thinner than the CVD, much useful for in finishing tool for getting a sharper edges. So what this mean? Basically, you within a physical vapor deposition process, you can control the rate of evaporation of the precursor material, or you can control the rate of evaporation of the source material, and that's the reason you can like in a pulse laser deposition, you control a rate of evaporation with the pulse of the laser. The electron beam evaporation, you can control the rate of evaporation with electron beam, and so on. So basically that's the reason that you can deposit ultra thin films and thin film with a physical vapor deposition process. Whereas though you can prepare ultra thin film with chemical vapor deposition processes, but still the CVD give you a thicker film as compared to a physical vapor deposition process. That's the reason the CVD, the PVD is that's the PVD coating may be much thinner than the CVD, and that's the reason this PVD is used in a finishing tool for getting a sharper edges. So now, dear student, there are also some techniques available. This is for researchers, okay? There are some techniques available in chemical vapor deposition process. One of the known technique is known as liquid injection chemical vapor deposition process, or atomic layer deposition process. So in liquid injection chemical vapor deposition process, you evaporate a precursor material or a source material by heating externally, but you can deposit the source material by controlling the injection of the precursor material inside the reaction chamber. So by controlling the injection, you can prepare ultra thin film with CVD process, but that is done usually at advanced level in advanced techniques like liquid injection chemical evaporation process. Overall, CVD process provides you a thicker film as compared to PVD process thin films. PVD is useful for the deposition or producing extremely hard Korean resistant coating. Now question here is that why PVD is used for extremely hard Korean resistant coating? Is I have previously discussed that with physical vapor deposition process, you evaporate a precursor or source material by bombarding high energetic electron beam, or by using energetic pulses of laser, or by using sputtering technique, or by using physical remover of the material by applying a sputtering. So all these techniques, when applied on the surface of the substrate, the small region which is converted due to a high energy of electron beam or due to high energetic pulses or due to high energetic sputtering, the small region which is ionized in the form of plasma of the source material have very high energy. This means that the movement of the plasma inside the reaction chamber in the form of a gases is very fast. The plasma has very high energy, and when the high energetic plasma, which is basically produced from a source material, is transported and interact on the surface of the substrate, they just do serious interaction with the surface. And that's the reason, due to a serious interaction of, due to higher energy of the plasma which is produced inside the reaction chamber, result into a very hard coating, very hard interaction of the plasma of the source material with a substrate. And that's the reason PVD is used where you need extremely hard coating and corrosion resistant coating. You cannot use chemical vapor deposition process for hard corrosion resistant coating. The reason is that with CVD you just evaporate a precursor material and transport it on the surface of substrate, and they chemically react with the surface of substrate. Their energy of the precursor material or source material is less, so the interaction of the source material chemically with the substrate is less, and even physically it is very less. And that's the reason the chemical vapor deposition process is not used for coating extremely, where you need extremely hard coating or corrosion resistant coating. Now, thin film made by with a PVD process have a high temperature tolerance and superior ablation resistance. Okay. So this means that the film which is deposited with a PVD process has high temperature tolerance. Even if you heat the film at a higher temperature, which is was on PVD, it is very difficult to evaporate the deposited PVD deposited thin films, and which means that the thin film deposited by a CVD process are superior in ablation. You cannot basically remove the material from the surface of an object by vaporizing, chipping, or by other kind of avian processes. So that means that if you need a high temperature tolerant processes, you need to deposit a film with a PVD processes. That's the reason the PVD is a core technique in a tooling industry, and it is also a core technique which is used in aerospace kind of applications, where high temperature is considered for the deposition. The thin film made with a PVD process has a higher resistance, as I have discussed it. Now, PVD is also considered as environmentally friendly process. Why PVD is environmentally friendly process as compared to the chemical vapor deposition process? Dear student, in PVD process you evaporate a precursor material, usually it is not hazardous, and transport it onto a surface of substrate, a same material onto the surface of substrate, and get a thin film. Whereas in chemical vapor deposition process, you basically evaporate a precursor material which is an organometallic, and it is usually hazardous, and when you transport it on the surface of substrate, they get chemical reaction, and due to a chemical reaction and deposition of thin film, you get a byproduct which is usually hazardous. And that's the reason that PVD is considered more environmentally friendly technique as compared to chemical vapor deposition process. PVD required costly, intense heating and cooling system. So this is the drawback of PVD, and that's the reason due to which you mostly use a chemical vapor deposition process, because you need a very costly setup to heat or to evaporate and convert the source material into a plasma. Like in electron beam evaporation process, you need electron gun, and it's set up in the electron beam evaporation reaction chamber. And similarly, in pulse laser deposition process, uh, which is a type of physical vapor deposition process, you need and costly laser setups. So this means that PVD process is more costly. Another drawback of PVD is a cooling system. You also need a cooling system, because in PVD you use hundreds of kilovolt of energy from electron beam and from the pulse laser or by sputtering. So when you bombard the source material with electron beam, pulse laser, or by high energetic ion of sputtered material or sputtered source, basically the surface of the precursor material get of the source or the source material become very heat up to thousands of degree of kelvins. So due to a high temperature, usually there may be a result into a impurities incorporation inside the plasma of the evaporated source material. So, and this, in order to decrease the temperature and to get highly pure material, you need a cooling system in physical vapor deposition process. Whereas the interesting fact to notice here is that for CVD system, though there are different kind of cooling system used, like water is used, but you don't need a mandatory cooling system for cooling the precursor material and substrate. But in physical vapor deposition process, you need a cooling system to cool the precursor or source material. So PVD process is more costly in terms of instrumentation for bombarding the source material and due to a cooling system which is used in a PVD systems. CVD produces hazardous byproducts which result into hazard is less in PVD. This means that in chemical vapor deposition process, usually you get hazardous byproduct. As you know that chemical reaction take place on the surface of substrate, so you get a thin film. As a result of chemical reaction, there are also produced hazardous byproducts. Even the precursors or reactants which you use in CVD are mostly hazardous, like organometallics. So the byproduct which is produced due to chemical reaction, they are exhausted into exhaust scrubber and then they are removed from the system. But still, the byproduct produced in CVD are usually hazardous, while in case of PVD, if you have a byproduct, they are not hazardous, or they are rarely hazardous. So that's the advantage of PVD over chemical vapor deposition process. Now, student, the interesting property of the CVD process is that with CVD process you can deposit uniform, evenly thin film on even the irregular surfaces. This is because CVD is not line of sight process. Okay, the reaction, the reactant in a form of gas, just they are incorporated inside the reaction chamber, and they get chemically reacted over the whole surface of the substrate without considering the roughness or irregularness of the surface of the substrate. This means that you get a highly uniform thin film or evenly thin film on a surface of even a rough substrate. Whereas, as I've discussed, that PVD is line of sight process, you basically get a deposited thin film in a specific certain direction, in a certain position of the substrate. Now that's the reason due to which you can get, like, you can have an evenly or non-uniform deposition in a physical deposition process as compared to a chemical vapor deposition process. For instance, a CVD is relatively an economical process than PVD or physical vapor deposition process. Why CVD is an economical process? Because the student, you in CVD you just need to evaporate a reaction precursor material or reactant and just transport them through carrier gases onto the surface of substrate. You just have a cost of the chemical reaction, while in case of physical vapor deposition process you need a special kind of system to evaporate, to transport a source material or to transfer a source material into a gaseous phase. These systems are usually electron beam guns or electron guns. They may be pulse laser systems and also a sputtering system, so ion guns, etc. So these systems are more costly as compared to a CVD system. Secondly, in PVD system you need a cooling system for a substrate, because you have bombarded the substrate material, you have bombarded the source material with highly energetic electron beam and with a pulse laser or with this ion gun. So for that you need a very smart kind of cooling system to cool the precursor material in order to avoid the impurities. So for that you need a costly system, whereas in case of CVD system you just need a reaction, you just need a reactant and evaporating setup for the reactant, which are usually done thermionically by applying a heater around the reactant material. So the PVD system is more economical due to instrumentation as compared to a chemical vapor deposition system. CVD coating are much thicker, and that's the reason they are used in thermo barriers. Thermal barrier mean that you can basically use to deposit an insulating kind of thing with a chemical vapor deposition process, and that basically avoid a kind of heating of the substrate material or damaging the materials on which the things was deposited by CVD process. The thin film deposited by a CVD process is adherent and more wettable than the PVD because of the chemical reaction and substrate temperature difference. Now, this is very interesting property, that you basically get an adherent, strongly interacted thin film with a substrate in chemical vapor deposition process, and more wettable thin film by using CVD process rather than chemical vapor deposition process. Why you get adherent and wettable thin film by chemical vapor deposition process? Different. Basically, in chemical vapor deposition process, a chemical reaction takes place on the surface of the substrate, which means that the chemical reaction which occur at the surface of the substrate may also cause a diffusion or with chemical diffusion with a substrate, and they make the film more adherent and wettable. Whereas in physical vapor deposition process, you basically physically deposit the precursor material onto the surface of substrate without any chemical reaction, and that's the reason that CVD process is more adherent and more wettable as compared to physical vapor deposition process depositing films.